Okay, so the next question that we're asked, we got on the menu today, is asking us, how do we find tan to the negative 1 of negative 1 without a calculator? Okay, so there are a couple of different ways that we can interpret this. Okay, so I'll write this out. Okay, so there are two interpretations. So this is, we have one, which is the inverse operation. Meaning that tan of, let's say x is equal to negative 1. X is equal to tan inverse of x. But typically it's better to write it as arctan, like this. It's better to write it as arctan so that we don't have the two interpretations problem that we have that I'm about to list out. Okay, so this is one. It's better to write as arctan if we're doing the inverse operation. Okay, and another interpretation is with the reciprocal interpretation. Okay, so generally this is less common, but like when we have a function, let's say we have like tan squared of x, this is equal to tan of x squared. Okay, so we move it on the function instead. So it would stand to reason, reasonably assume that tan to the power of negative 1 of x is equal to tan of x to the power of negative 1. And this is the same as saying equal to 1 over tan of x. Okay, and this is often written as cotangent of x. Okay, so you can see generally it's not great to write your functions like this, especially with like trigonomic functions to the power of negative 1, because we can interpret it two different ways. It would be better to write arctan or better to write cotangent so that there is no opportunity to get this confused. Okay, so now the question is saying to find this without a calculator. Okay, now if we just do it this way with the reciprocal interpretation, that's gonna be quite difficult because it's basically saying like at an angle of negative 1, what is the rise over run? Okay, so that's gonna or what's the reciprocal? Like we would have to find the tan of negative 1, and negative 1 is the angle. That's rather difficult to do without a calculator. So we're going to assume that we're going to go down the inverse operation. Assume this way. Because an angle of negative 1 is difficult to deal with without calculator. Okay, but in general, when you see negative 1 or to the power of negative 1, in general it's going to be more it's much more likely that there is going to mean the arc operation, so like arc sine, arc cos, arc tan. But you know, sometimes just because of this rule, like you can sometimes argue that it means the reciprocal. So stay ready for that. Okay, but in general, it's going to mean the arctan when you have the negative 1. Okay, so let's actually see what this means. So this is saying that let's actually think about this question a little bit more. Okay, so we have basically this. So we have when we think about our coordinate graph, like this, we have x and y, and let's also think about a right angle triangle, like that. And suppose here we have our theta angle, here we have our op, here we have adjacent, and we know that tan theta is equal to opposite over adjacent. Okay, so what it's basically telling us is that the opposite over adjacent is going to be -1. Okay, so this is following this path. We're trying to find what that is equal to. Like we're basically setting this to x. Yeah, actually, whoops, I should not write that these are for -1 as argument. Okay, so you see, like, we're just inverse tanning both sides. So the -1 is equal to opposite over adjacent equals -1. Okay, so we want to find the minimum angle where this is going to be true. So there are two options. There's either like we're either going to have op as 1 going this way and adjacent as -1 going this way, or we're going to have +1 and -1 for the angles. Okay, so we're looking for wherever the angle it makes so that we get either one of these. Either we get rise, so either rise 1, run -1, or we get rise -1, run 1, and this will make opposite over adjacent equal to -1. Okay, so if we want to make if the rise is 1 and the run is -1, let's actually highlight that in blue. Okay, so this would be 1 and this would be -1. Okay, and you know, our related acute angle is this, but our actual angle comes from there. Okay, and in red, let's do this case. So we have rise of -1 and run is equal to 1. And this would be the second case, and our total angle would be that, and this is our related acute angle, our AA, and I'll go back to blue and write that in here as well, RAA. Okay, so as you can see, since regardless it has to be you know, the magnitude of the rise and run are the same, we know that the angle has to be 45 degrees. So any triangle that looks like this, or I'll actually write out that the magnitudes are the same. Of rise, whoops, run must be the same. Magnitudes meaning like if you just convert it to an absolute value. So this is the magnitudes of those are the same. Must be 45 degrees for the related acute angle. Okay, because we know that when we have 45 degrees here, these two must be the same size. Okay, isosceles triangles have 45 degrees. Oh, or this particular isosceles, not all isosceles, but any triangle that has a 45-degree angle has to be isosceles. Okay, so yeah, so that's how we know that this angle here, this is 45 degrees, and this right here is 45 degrees. So now we want to see like the first one for blue total angle. This is going to be 180 degrees minus 45 degrees. The blue total angle is this one right here. Okay, and you can see like the one where 180 degrees is like to the negative x-axis, and we're just subtracting 45 degrees from that, so we're gonna get 135. Okay, and the red total angle, which is this guy, this is just 360 minus 45 degrees. Okay, so it's like basically we're doing a whole loop, but then just reverting the 45 here. So that would be 315. Yeah, 315 degrees. Okay, so those will be our two answers, 135 degrees and 315 degrees. Okay, so another way that we could write 315 degrees, you could also just say this is negative 45 degrees, because that's like, this is our zero angle. Okay, so just remember your, typically you're going to go for the inverse operation when you see to the power of -1 most of the time, but sometimes it can be ambiguous and we might need to go the reciprocal route. It really depends on the context. And then once we realize that we're doing the arctan, the inverse operation, we know that the ratio between the opposite and the adjacent is 1, or is -1. So we know that their magnitudes have to be the same, and that one of them is negative. We don't know which one, so we have to give the possibilities for both of them. We can have is negative and the run is positive, that's the red one, or we can have the case where the rise is positive and the run is negative, and that's the blue case. And we have to have both of those options. And pretty much in any trigonometric situation, you're gonna have, and you're thinking like in the like more than in the whole 360 degree playing field, you're generally gonna have two answers anytime you have like an inverse operation. Okay, so yeah, hopefully that helps clear things up in this question. And oh, they also, so this is like the angle relative to relative to just like one cycle, but we also know that we can have many, let's say you want to have an angle of like 3,600 degrees, like 10 whole revolutions, and then you start recording the angle. That's another possibility. So it would actually be even more correct to say that blue total angle, this is going to be 360 degrees to the power of n plus 135 degrees, and then n is an element of the integers. Okay, so n can be any non-decimal number, 1 2 3 4 5 0 -2, anything like that. Okay, and it's all going to work out, and we got to add that same type of factor for our red term, but we can really just do not minus the 45 degrees, because that's just as valid to write. So we can just do 360 degrees times n minus 45 degrees, and n is an element of these integers. Why is it written as a z? I guess I is maybe too confusing with the number 1, so that could be why. Okay, but yeah, so we do have to consider as well, you know, over rotations. Like you already spun around 4 times before you're taking this angle, but it should all still work out the same. You just have to add this little term. Here they converted it to radians, but of course it's pretty much the exact same thing. Okay, so awesome.